Friends, how is your board exam preparation? I have collected few important board questions for you. Watch the complete video to find the answers of them. If you are new here, please subscribe the channel and press the bell icon for the future updates. Find integration log of log x plus 1 upon log x whole square dx. It is taken from CBSE 2016. Let us consider that log of x is equal to t. Okay, it implies that x is equal to e to the power t, and so that dx is equal to e to the power t dt, isn't it? Therefore, I is equal to integration log of log x means log of t plus 1 upon t square. 1 upon log x whole square means 1 upon t square dx. And what is dx? Dx is equal to e to the power t dt. So this is equal to, this step is very important, integration log of t plus 1 upon t minus 1 by t. This part is extra, we have introduced here, plus 1 by t minus 1 by t and plus 1 upon t square as usual, e to the power t dt. So friends, we now split in two parts, integration log of t plus 1 upon t e to the power t dt plus integration minus 1 upon t plus 1 by t square into e to the power t dt. So friends, we have one formula. The formula is very important of integration. The formula is this one. Integration of fx plus f dash x into e to the power x dx is equal to f of x into e to the power x plus c. So friends, you see that the derivative of log t is equal to 1 upon t. So we can write e to the power t into log t, e to the power t into log of t plus minus 1 upon t plus 1 by t square. What is the derivative of minus 1 upon t? The derivative of minus 1 upon t is plus 1 by t square. So according to this formula, the resultant will be e to the power t into minus 1 upon t. So we can write minus 1 upon t into e to the power t plus c. So now putting t is equal to log of x, we get I is equal to e to the power t and t is equal to log of x. So log of x into log of t, that means log of log x, minus 1 upon t means 1 upon log of x into e to the power t means e to the power log of x plus c. So friends, you know another form, e to the power log of x is equal to x into log of log x minus 1 upon log of x, and e to the power log of x is only x, so we can write x upon log of x plus c, hence the result. You now see the next example. Next question is evaluate integration 1 to 4 f of x dx, where fx is equal to modulus of x minus 1 plus modulus of x minus 2 plus modulus of x minus 3. It is taken from CBSE 2017 and it is very important question. Friends, the solution is this one. Integration 1 to 4 f of x dx is equal to, we write the function integration 1 to 2 f of x dx plus integration 2 to 3 fx dx plus integration 3 to 4 f of x dx. Okay, now we replace this fx by the given function. Integration 1 to 2, now friends, you see that if you take any value in between 1 and 2, the modulus x minus 1 will be positive, so we write x minus 1 only positive value. And if you put here any value in between 1 and 2, and it will be negative, So this is minus of x minus 2. Similarly, you take any value in between 1 and 2, say 1.5. So 1.5 minus 3 is a negative quantity, so I write minus x minus 3. In this way, the other integrals plus integration 2 to 3 f of x will be now x minus 1 plus x minus 2 minus x minus 3 dx, and integration 3 to 4 f of x, this one will be x minus 1 plus x minus 2 plus x minus 3 dx. So friends, it is equal to integration, first one, integration 1 to 2, this is x is cancelled, minus x plus 4 dx, plus integration 2 to 3, this x is cancelled, so only x dx, plus integration 3 to 4, and this is x plus x, that is 3x minus 6 dx. So after integration we are getting minus x square upon 2 plus 4x, limit is from 1 to 2, plus this is x square upon 2 from 2 to 3, plus 3 is taken common, so x square upon 2 minus twice of x, limits from 3 to 4. So we are getting minus 4 upon 2 plus 8 minus, that is plus half, minus 4 plus 3 square means 9 upon 2 minus 4 upon 2 plus 3 times 16 upon 2 minus 8 minus 9 upon 2 plus 6, isn't it? So after calculation we are getting here only 5 upon 2, and from here we are getting 5 upon 2 again, and from this one, yes, this 8 is cancelled, and getting 9 upon 2. So after calculation we are getting here 19 upon 2. So the result. So this is, it's an important question. It came into CBSE 2017. It may again come in your next examination, and so please repeat this answer again and again in your copy, and you will be helpful. Go to the next question. Friends, it is one of the most important questions. Evaluate integration 0 to pi by 2 root over 10x plus root over cot x dx. It came in CBSE 2014. So your solution is this one. I, integration 0 to pi upon 2, we write 10x by sin by x, so it will be root over sin x upon cos x plus root over cos x upon sin x dx. Okay, so this is equal to integration 0 to pi upon 2, we take an LCM here, so the LCM is root over sin x cos x, and in numerator we are getting sin x plus cos x dx. So friends, this is we can introduce in root 2, so there is outside root over 2, integration 0 to pi upon 2 sin x plus cos x divided by root over 2 sin x cos x dx. This is equal to again root over 2 integration 0 to pi upon 2 sin x plus cos x root over, we introduce another important step. Actually this is an important step. We introduce 1 plus 1 and minus 1. Okay, 1 minus 1 is equal to 0, and this part is as usual plus 2 sin x cos x. Now what is the purpose of this step? This is very important step because you can write this one as sin square x plus cos square x. So ultimately we will get root over 2 integration 0 to pi upon 2 sin x plus cos x upon root over 1 minus sin x minus cos x whole square dx. Okay. Now we shall substitute. Putting sin x minus cos x is equal to z. We get cos x plus sin x dx is equal to dz, isn't it? So we have to change the limit. When x is equal to 0, then t is equal to minus 1. And when x is equal to pi upon 2, then t is equal to 1. So the integration will be now I is equal to integration, root 2 is outside, integration minus 1 to 1 dt upon root over 1 minus t square. Okay. So this is equal to root 2 sin inverse t, limits minus 1 to 1, and it is root 2 sin inverse 1 minus sin inverse minus 1. So getting root 2 into 2 sin inverse 1. Now what is sin inverse 1? Sin inverse 1 is equal to pi upon 2. So we can write root 2 into 2 into pi upon 2. So 2 is cancelled. We are getting only root 2 pi. This is actually the result. So friends, this is an important question. You should practice it at your home. Evaluate integration 0 to pi by 2 root over 10x plus root over cot x dx is equal to root 2 pi. Our next question is integration 0 to pi x 10x upon sec x plus 10x dx. It is repeated twice in 2008 and 2017. Friends, I is equal to integration 0 to pi x 10x upon sec x plus 10x dx. Okay, we consider it as I. Now we have one property of definite integration. It is integration 0 to a of fx dx is equal to integration 0 to a f of a minus x dx. We shall use this property. This is an important property of definite integration. So friends, we are getting 0 to pi x. In place of x, we shall write now pi minus x into 10 of pi minus x divided by sec of pi minus x plus 10 of pi minus x dx. This is equal to integration 0 to pi minus x. What is 10 pi minus x? 10 of pi minus x is equal to 10x minus 10x, and sec of pi minus x is equal to minus sec of x, and 10 of pi minus x is minus of 10x dx. So friends, we are getting integration 0 to pi minus x whole into 10x divided by sec x plus 10x dx. We mark it 2 and the first one is 1. Now friends, by adding 1 and 2, we get 2i is equal to pi integration 0 to pi 10x upon sec x plus 10x dx. Now the next step is very important. Multiplying and dividing by sec x minus 10x What is the purpose to multiply again by dividing by the quantity sec x minus tan x? Because if you multiply the denominator by sec x minus tan x, then the denominator will be sec square x minus tan square x. So this is the benefit. Actually this is equal to 1. So we are getting 2i is equal to pi into integration 0 to pi sec x tan x minus tan square x dx, isn't it? Because the denominator will be now sec square x minus tan square x, and sec square x minus tan square x is equal to 1, and the numerator is this one, sec x tan x minus tan square x dx. So friends, we are getting 2i is equal to pi into integration 0 to pi sec x tan x dx minus pi into integration 0 to pi tan square x dx. Pi into, this integration 0 to pi sec x tan x means sec x, and the limit is from 0 to pi, minus pi. Do you know the integration of tan square x? No, actually we have to replace this tan square x by sec square x minus 1. You know this 1 plus tan square theta, 1 plus tan square x is equal to sec square x, isn't it? So sec square x minus 1 is equal to tan square x. So we replace this tan square x by sec square x minus 1. So getting pi tan x, limit from 0 to pi, plus pi x 0 to pi. So friends, this is pi into minus 1 minus 1 minus pi, tan pi is equal to 0 and tan 0 is also 0 into 0, plus pi into pi minus 0. This is pi minus 0. So we are getting minus 2 pi, and this is pi square. Ultimately what are we getting here? Pi into pi minus 2. This is the result. So this is also another important question, and it is repeated twice in 2017 and 18. Integration 0 to pi x tan x upon sec x plus tan x dx is equal to pi into pi minus 2. We shall go to the next question. Our next question is evaluate integration pi by 4 to pi by 2 e to the power twice x into 1 minus sin 2x upon 1 minus cos 2x dx. It is taken from CBSE 2015. So let's start. I is equal to integration pi upon 4 to pi upon 2 e to the power twice x into 1 minus sin 2x upon 1 minus cos 2x dx. We considered it as I. Okay. So friends, we can write it as integration pi upon 4 to pi upon 2 e to the power twice x into 1 minus 2 sin x into cos x upon 1 minus cos 2x. You know this form, it is actually taken from trigonometry. This is 2 sin square x dx. So this is equal to integration pi upon 4 to pi upon 2 e to the power twice x into half cos x square x minus cot x into e to the power twice x is taken here, so only dx. So friends, let us consider that twice x is equal to t, that is x is equal to t upon 2 and dx is equal to dt upon 2. Now we have to change the actually limits. If x is equal to pi upon 4, then t is equal to pi upon 2, and if x is equal to pi upon 2, then it implies that t is equal to pi. Therefore I is equal to integration pi upon 2 to pi and e to the power twice x is now e to the power t only into cot t upon 2 minus half cos x square t upon 2 dt. This is equal to minus half integration pi upon 2 to pi e to the power t cot t upon 2 minus half cos x square t upon 2 dt. That is equal to minus half into integration pi upon 2 to pi e to the power t cot t by 2 dt minus half integration pi upon 2 to pi e to the power t cos x square t upon 2 dt, isn't it? So now we shall only use the by parts rule here. Okay, so our integration will be now minus half integration. Here if you use eyelet, then you have to take e to the power t as the second function. So cot of t by 2 is the first function. So this is e to the power t into cot of t by 2, limits from pi by 2 to pi, plus half integration pi upon 2 to pi e to the power t cos x square t upon 2, and the remaining part is as usual minus half integration pi upon 2 to pi e to the power t cos x square t upon 2 dt. Now see that these two parts are same, so we can cancel this one and that one. Okay, so the remaining part is now minus half e to the power t cot of t by 2, limits from pi by 2 to pi. Okay, so you are getting it as minus half e to the power pi cot of pi by 2 minus e to the power pi by 2 cot pi by 4, isn't it? So we are getting the result like minus half 0 minus e to the power pi upon 2. So ultimately this is e to the power pi by 2 whole divided by 2. So the result. So friends, the integration of e to the power, integration pi by 4 to pi by 2 e to the power twice x into 1 minus sin 2x whole upon 1 minus cos 2x dx is equal to e to the power pi by 2 whole upon 2. So